second question, that is show that diagonals of a square are equal and bisect each other at right angles. We have to show a square is given and the diagonals of a square are we have to show it is equal and bisect each other at right angles. So this is a given question, that is ABCD is a square. So what is given? Given ABCD is square. To prove, we have to prove the diagonals of a square are equal. That is AC is equal to BD. And also they are equal, we have to prove, and also they bisect each other at right angles. That is they bisect each other. That is AO is equal to OC, and that is we have to prove diagonals bisect each other at right angles. So these two things we have to prove. Okay, so now let's take these two triangles. That is triangle DAB. That is DAB and triangle CBA. Triangle CBA. Okay, now what is that? The sides of the squares are equal. So in this triangle and in this triangle, AD will be equal to BC. AD equal to BC. And now we know angle A and angle B are 90 degree. That is angle A equal to angle B equal to 90 degree. And also AB is a common side. AB is equal to AB. Therefore, these two triangles are congruent. That is triangle DAB is congruent to triangle CBA. Which congruency? SAS. That is SAS congruency. Okay. So, these two triangles are congruent. So, therefore, AC is equal to BD by CPCT. AC is equal, therefore AC equal to BD by CPCT. Now we have proved the first one. Now we have to prove diagonals bisect each other at right angles. So now first we will prove that the diagonals bisect each other. That is OA will be equal to OC and OB equal to OD will prove. Okay. So now for that, let's take triangle OAD and triangle OCB. Okay, triangle OAD and triangle OCB. Okay, now in this triangles, you know, these two are equal by vertically opposite. That is angle DOA is equal to angle BOC by vertically opposite angles. Okay, and now this is equal, and now these two sides are equal and also parallel, no? So these angles, this angle and this angle will be equal, right? By alternate interior angles. When this is the that is AC is a transversal of parallel lines AD and BC, then DAO will be equal to OCB. Okay, that is angle DAO is equal to angle OCB by AD parallel to BC and AC is transversal. Okay, therefore alternate interior angles. Okay, that's why they are equal. Okay, now what? This angle, this. Now you know AD will be equal to BC. It's given. It's a square, no? Now AD is equal to BC. Why? Sides of square. Okay. So now therefore what? By AAS congruency. Then triangle OAD will be congruent to triangle OCB using AAS congruency. Right? So therefore what? OA will be equal to OC and OD will be equal to OB by CPCT. Therefore OA is equal to OC and OD is equal to OB by CPCT. Therefore diagonals bisect each other. Okay, we have proved one part of the second, that is diagonal bisect each other. We have proved. Now we have to prove whether they are bisecting at right angle, that is this angle should be right angle, that we have to prove. Okay, so for that we'll take these two triangles, that is ODA and ODC we'll take. Okay, triangle ODA and triangle ODC will take. Okay, these two triangles will take. So this is a common set, is OD, they are common, and these two sides are what? Are equal because it's a square. And also we have proved OA equal to OC. We have proved, no? That is diagonals bisect each other. So therefore by SSS congruency these two triangles are what? Congruent. Now what is that? OD equal to OD. Okay, same side, common side. Now AD equal to CD. Sides of square. Okay, now OA equal to OC. Proved. Therefore by triangle ODA is congruent to triangle ODC. SSS congruency. Okay, so look, these two angles will be equal, that is what? These two, that is this will take as one angle 1 and angle 2. So here angle 1 and angle 2 will be equal, and but they also form a linear pair. So angle 1 plus 2 will be 180, then angle 1 will be 90. We have done similar problems, no? Okay, so I'll write it here. Okay, so therefore what? Therefore angle 1 will be equal to angle 2. Okay, and angle 1 plus angle 2 is why this is CPCT. Okay, will be 180 degree by linear pair. Okay, therefore angle 1 is equal to 90 degree, and also angle 2 is 90 degree. Okay, so now we have proved the diagonals bisect each other at 90 degree. Similarly here also it will be 90 degree. Okay, so now we have proved this also.